Hi everyone, welcome back to the channel, and today we solve Leetcode daily challenge problem number 787, cheapest flights within K stops. So it's a medium level problem, and we'll first check out the problem statement, then we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it says there are n cities connected by some number of flights. You are given an array flights where flights of I represents from, to, and price. So basically it represents source, destination, and price. Indicates that there is a flight from city 1 to city 2 with a cost price. You are also given three integers, source, distance, and k. Return the cheapest price from source to destination with at most k stops. If there is no such route, return -1. So let's take this example. In this, there are four cities, 0, 1, 2, 3. Okay, and all the weights on these edges basically represents the price, or I would like to see this as a distance between 0 to 1, 1 to 3, and so on and so forth. Okay, so what I have to do, I have to find out the cheapest possible path from a city 0 to, like, from a city S to city Y with this weights. Okay, so this is the crux of the statement, and there is another variable called k. That means we can have at most k intermediate cities which we can stop at. Okay, for example, let's say we have to reach from 0 to 3. 0 to 3, the potential path is 0 to 1, 1 to 2, and 2 to 3, and another path is 0 to 1, 1 to 3. So we will be, we won't be able to go for the other path no matter if it is a smaller one or not, because the number of stops will be greater than k. Okay, that's why we are taking the path with higher weights. So let's check out the approach which we can use to solve this problem. Okay, so here is the approach which you can use, in which first of all we'll be using breadth first search to you know to solve this question. And what I will do, I would like to first mold the given information of this route from city X to city Y and the price into something like this. For example, I'll have a dictionary where I'll take a key. Okay, this will be treated as a source from, like, a local source, you can say, just to not get confused with this source. And I'll write down all the cities I can reach out to. For example, I can reach out to one with price 100. Okay, there is no other, right? Similarly, in we have one, and we can reach out to 2 with 100, sorry, 2 with 100, and 3 with price 600. Next we have 2, you can reach out to 0 with price 100, and we have 3, and it will be empty because there is no outgoing edges from this one. So this is kind of a hash map which I will prepare. Next is distance. So this is the distance from the given source to any of the node. Okay, and initially I'll keep it infinity, sorry, I'll keep it as infinity for all the cities. Okay, we'll keep this infinity, and I have done this to just make the life simpler, to make the calculation simpler. And of course, like, if you're starting from any node or any city, the distance from that city to itself will be 0. For example, in this case city is 0, so I'll replace the index of this with 0, because source to source is 0, of course. Okay, next is I am maintaining a queue. Okay, in this queue I will keep a track of what all nodes I have already seen, and I'll also keep a track of the minimum distance possible, like minimum price I'll have to pay to get to the city from the source. Okay, and it will be a queue. Next, what I want to do, I want to run a loop. I want to run a loop where the condition is my queue should not be empty, queue not empty, and my number of steps is less than or equal to k. Okay, I want to run a loop with this condition. Okay, so now we have all these variables. There is one more which we are tracking, which is called steps. Initially it will be 0. Okay, and now I want to run a loop. What I will check, so we are running a BFS, right? So I will check the number of elements I currently have in the queue. Okay, for example, if you are at source, you can keep all the nodes you can reach out to from any particular source node. For example, if you are at 1, you will have 3 and 2 in the queue. Okay, so I will check the size of queue, okay, by simply taking the length of the queue which we are maintaining. Okay, so this will give you the size, and basically you can now run a loop for this particular size. Okay, now again I'll run a loop for all the elements in the queue. Okay, so basically I want to pop the elements one by one. Okay, and I want to process it further, so I'll run loop in range what size of queue. Okay, now what we want to check, so every time you enter this loop, you will pop a element, pop from queue, and this will give you two values, right? First will be I think I should write it a little here. Okay, the first value is what? Your current source, okay, and price from the actual source. Okay, you will get this value on each of the pops. So for example, you started at source which is 0 0 you have currently. Okay, now you entered this loop because queue was not empty and number of steps is less than equals to k. K is 1. Now the size of queue is 1. Why? Because we just had a single element over here. Now what you'll do, you'll do a pop, you'll receive a source and the price from the source itself. Okay, so currently it is 0 because if you want to go from city X to city X itself, the distance will be 0 and the price will also be 0. Okay, in this case, now check. Now comes this hash which we prepared for all the adjacent cities. For what I want to do, I want to now explore all the options I can go from our current source. Okay, so I want to check what all cities are accessible. For example, in this case we are at 0, right? So what I'll do, adjacent, and we will use current source for it. So every time you'll try to look for a key, you'll get at least two values, right? It's an array. So first one is the destination you can go to, and the other is how far or how much you'll have to pay for reaching there. Okay, so I took two values from there. Every time, what I do now, I will check if the price I have paid to reach to a node plus the amount which I'll be paying to reach to another node. For example, we reach to 1, okay, by paying 100. Next I want to reach to 2 and I'll have to pay another 100. Okay, if it is less than or equal to what we have already seen for that, for example, what we are trying to do, we are trying to get the smallest amount which we have to pay to reach to any particular node. Okay, if it is smaller than what we have in this array, in this distance array, then we will update the value. Okay, so if what price from source plus destination price is smaller than is smaller than the distance which we have already listed for the current city, then we will update. Okay, so for here, like in this case, we'll have 1 and 0. Okay, so my cdest will become, let me change the color, cdest is 1. Okay, and destination price will be 100. So now I will check if I if there is another way to reach, which we have already seen, to 1 with the minimum spend. So from 0 to 1, of course it is 100, because 0 plus 100 will be 100. So I'll update this infinity with 100. Okay, and we will just simply add the what is it, the destination which we just processed. Okay, and the price it will took me, which will be what, this value, right, to c test. Okay, in the queue. Okay, I'll add this in the queue, so that we can reference it anywhere. At the end, what you'll have to do, you'll have to just find out what is the value at the array, at this distance array, for the destination which we were looking at, and if it is infinity, we will return -1, otherwise we'll return the value. So this is the complete logic for it. So let's check out the code for the same. Okay, here's the code. So what we have done over here, we have used default tick to give a default value for all the keys, so that we don't get any key error, and we are traversing the flights array which we have received, and preparing the agency city hash, or dictionary, whatever we would like to say. Okay, it's exactly like what we saw on the explanation. Next is, I have defined an array with all infinities in it, and we have updated the value of the source which we have received in the problem statement, to 0, because if you want to reach city X from city X itself, it will be 0. Next, we started or initialized a queue with the source initially, and stops being 0. After that, like, we are running a while loop until our stops is less than or equal to k, and we have valid entries in our queue. Okay, we are running a breadth first search, that's why we are calculating the size, so that at each point we just process the nodes which were there at the starting of the loop, and we don't process all these values which we are appending in the later phase of the code. So we will again, after that, like, we will pop all those elements which we have in the queue at the moment, one by one, and we'll have the source and the price for it. Okay, so like, whatever element will pop, that will be treated as our current source, and source price will have basically will store the information of how much we have paid to reach to that particular node. Next is, we are referring to the adjacent cities which we can go from the current source, and we are getting all the destinations and their prices. And the motive behind this is to update the distance array with the minimum possible price possible to reach to that city. Okay, so we are doing that over here, and we are adding the same node and the distance value in the queue. And once we are done with this part, like, we are adding our stops with +1, because of course, like, we have reached to another city on our way to reach destination. At the end, we are just simply returning the current value at the distance array which we had. If it is float infinity, like if it is infinity, we will return -1. So this is a complete code. Let's check out the test cases. And the test cases got clear. Let's submit it for further evaluation. And as you can see, the test cases got clear, and we have performed very well. We have performed around 93.17% of the submitted solutions. So yeah, thanks again, guys, for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.